Very good evening. Welcome to the course of Cryptography and Network Security. I'm delighted to take upon a session on cryptography and network security. So, in due course of time, we are going to have some important sessions relating to cryptography. So, before we understand the course, we try to know the importance, or we try to know why do we have to study cryptography. So, as we all know these days, a cyber attack is being rampant, and the attacks are being widely spread, and there are number of attacks which are attacking, or the number of attacks on the data. So, as an example, what do you mean by cyber attack? A cyber attack is a malicious and deliberate attempt by an individual or organization to breach the information system of another individual or organization. Right? So, cyber attack is mainly focusing on uh, the information system which is connected or which is belonging to an individual or an organization. Usually, the attacker seeks some type of benefit from disrupting the victim's network. So, the main concept, the main focus or main concentration here is the attacker or a hacker is targeting the data, the confidential data, and trying to disrupt the victim's network. So, cryptography is one such kind where the data is being protected, the data is being safeguarded so that the hacker will not understand or will not try to attack or breach the data. So, cryptography and network security. We have two words over here. Cryptography means the study of hiding the data with the help of encryption and decryption. And what is network security? Security provided uh, to the network when we communicate with each other. Right. So let's get into the details of cryptography and network security. Secure communication needs some requirement. What are the requirements of communication? And it should be secure. So we have three factors over here. One is secrecy, maintaining secrecy, and authentication, and message integrity. What is secrecy over here? Only intended receiver understands the message. Who is it? Who is this intended receiver? Intended receiver is the authorized person who has a right to receive the message and read the message. Second is authentication, wherein we try to confirm the identity of each other. Third one is message integrity, ensuring that the communication has not been altered, either maliciously or by accident during transmission. So, what do you mean by altering the data? If it is altered, the data is being altered, then we can directly say that the integrity is not maintained properly. So I can give you a formula here. Message sent is equal to message received. It means what? Whatever message is being sent at one side, the same message is being received without any alteration. Right? So these are the requirements of secure communication. And before we move on to the details of some more details of cryptography, we have to understand the concept of CIA triad. So, what is CIA here? C stands for confidentiality, I stands for integrity, A stands for availability. So, what do you mean by confidentiality? So, whenever a security system has to be built, if the security system has to be built, it has to be built upon this CIA model. The CIA model consists of three components or three factors. One is confidentiality. What is this confidentiality? Confidentiality is roughly equivalent to privacy. So, confidentiality measures are designed to prevent sensitive information from unauthorized access attempts. So, it is a common for data to be categorized according to the amount and type of damage that could be done if if it fell into the wrong hands. So what we are trying to do here, we are trying to prevent sensitive information from unauthorized access. So who is unauthorized access? The third party or the third person. So he doesn't have any authorizations to read the message and to hack the data. So this is the first factor of CIA triad. The second one is integrity. What is integrity? Just now we have discussed. Integrity is the uh, process or method wherein the data is being not altered. The sender is sending a message, and the same message is being received by the receiver without any alterations. Henceforth, we can say that the integrity is maintained. And third one is what? Availability. What is availability? Availability means information should be consistently and readily accessible for authorized parties, even it be a sender or even it be a receiver. If both are the authorized parties, the information should be consistently and readily available for the two parties. So this involves properly maintaining hardware and technical infrastructure and systems that hold and display the information. So, why we are discussing about CIA triad? So, if any a security system has to be built, it has to be built upon this model. So, any cyber professional has to take into consideration or put in some efforts to build the security system on this CIA triad model. right? Next comes our focus, that is cryptography. So what is cryptography here? Cryptography is the science of secret or hidden writing. So what we are trying to hidden here, what we are trying to hide here, we are trying to hide the data. Why? Because the attacker has every possibility to uh, attack the data which is confidential. So it has two main components. One is encryption, decryption. Second one is authentication and integrity. So how we try to hide the data? With two components or two methods. One is encryption and second one is decryption. So what is this encryption here? Encryption is a process of converting the plain text into ciphertext. What is plain text here? The plain text is a text which is in the readable format. What is the ciphertext here? The ciphertext is the text which is not in the readable format. In this way, we are trying to protect the data from the third party, right? So encryption is a process of converting plain text into ciphertext. Decryption is trying to convert the ciphertext into the original text, that is plain text. And second point is that authentication and integrity, ensuring that users of data or resources are the persons they claim to be, and that a message has not been altered, right? So we are trying to confirm the identity of each other, and not only that, we are trying to maintain the integrity. It means what? We are not trying to alter the data during the communication, or we tend to see that the data is being not altered during the communication. Next, encryption. So you can see here a plain text gets into the encryption algorithm, and it converts into ciphertext, and the ciphertext is again decrypted, in turn converted into plain text. Now, in both the processes, what we are trying to do here is we are trying to provide the keys. So with the help of the key, we try to encrypt. So key is the prominent component in trying to encrypt the plain text. So encryptional algorithms are standardized and published. So the key which is an input to the algorithm is secret, right? So knowing the key, or if I know the key, I can decrypt the ciphertext. So key is a string of number of characters. If same key is used for encryption and decryption, the algorithm is called symmetric. If different keys are used for encryption and decryption, the algorithm is called asymmetric key, right? So key can be of multiple sizes, multiple bits. The size of the key ranges. We have a certain range of the key bits. Let's see that. So symmetric algorithms. What are the examples of symmetric algorithms? Algorithms in which the key for encryption and decryption are the same, we call it as symmetric key. If the key is different uh, during the encryption and during the decryption, then we can say that the it is asymmetric key. So types we have block ciphers and stream ciphers. What is block cipher? Encrypting the block at a time, we call it as a block cipher. What is stream? Encrypting the data one bit or one byte at a time, we call it as stream ciphers. So, what are the examples for symmetric cipher? Here we have one example, that is Caesar cipher, and also some examples like DES, data encryption standard, and we have like blowfish algorithm, idea algorithm, so on and so forth. Even AES algorithm comes under symmetric key algorithm. Next. So, what can be the key strength? Strength of algorithm is determined by the size of the key. The longer the key, the more difficult it is to crack. So, as the size of the key is increasing, the complexity to crack is also increasing. So, the key length is expressed in bits. Typical key size vary between 48 bits and for 448 bits. What are the set of possible keys for a cipher? We have 40-bit key. There are 2 power 40 possible keys. Next is 128-bit key. There are 2 power 128 possible keys. Each additional bit added to the key length doubles the security. So to crack the key, the hacker has to use brute force method. So he tries all the possible ways in order to find out the key. So supercomputer can crack a 56-bit key in 24 hours. It will take 2 power 72 times longer to crack a 128-bit key. Now you can see the range here. So 56-bit key is it can crack in 24 hours. When it comes to 128-bit key, takes 2 power 72 times to crack. So longer than the age of the universe. So this is the strength of the key. Next comes the example of Caesar cipher. So which can also be called as substitution method. So what is the Caesar cipher? The Caesar cipher is an algorithm where we try to uh, convert the plain text into cipher text. So what method, what uh, logic we use in this method, that we have to understand. So Caesar cipher is a method in which each letter in the alphabet is rotated by 3 letters as shown. Now you can see if I give a key size of 3, you have A to Z alphabets at one point, and the substitution alphabets on the other hand. So if I give a size, key size 3, then we can say that the alphabet is rotated by 3 letters. Now A is rotated by 3 letters, you get D. B is rotated by 3 letters, you get E. C is rotated by 3 letters, you get F. D is rotated by 3 letters, you get G. And E is rotated by H, you get E is rotated by 3 letters and you get H, and so on and so forth. So this is all about Caesar cipher. So this is the outdated or the old algorithm. In the olden days, Caesar cipher has introduced this algorithm in order to communicate with his soldiers. So he used a method called Caesar cipher algorithm. So this is the method wherein we try to rotate the alphabet by 3 letters. You can see here, it's the same example. So plain text, what is the plain text here? Attack at dawn. So that plain text is being converted into ciphertext, and we are providing a key here with size 3, and you get the ciphertext wherein A is turned out to be D, T is turned out to be W, and again T is turned out to be W, and so on and so forth. In the same way, decryption process works out reverse. Again, the key size is given 3, and the letters are rotated by 3. So this is about Caesar cipher. So by this, we had understood what is a cryptography, why we have to get into the course of cryptography, and what is encryption, what is decryption, what are the symmetric key algorithms examples, and this is one among that example of symmetric key. So by this, we will conclude it today, and in the next class, we are going to learn the other algorithm which is relating to symmetric key, and that is data encryption standard. And some more details we are going to understand, and so that you get uh, you get the full understanding about the algorithm which is on DES. So until then, we I sign off, and we'll meet in the next class. Thank you.